Hello and welcome to the project. Yesterday we looked at the DOM, the document object model, and we created all the various classes that we needed for that. Okay, so we'll move on now, and today we're going to deal with the parser. We had a little sort of dummy parser from an earlier video that was just there in order to run the tokenizer, and it collected up descriptions of what each of the tokens was and made a string out of those, which it returned back to the UI. So we don't want to do that anymore. The parser in reality will return the DOM, which is the tree, and it returns that by returning a reference to the root node, and the root node will always be DOM document. So we're not building up a string anymore. We need to create a tokenizer, but we also need to create the document. And the parent node for the document, because it's the root, the parent node is nil. It doesn't have a parent. So let's get the first token from the tokenizer. And then we're going to have a loop, an infinite loop. And then at the end, we're going to be returning that document. So what do we do in the loop? Just like the tokenizer, the parser has the complete algorithm that it needs to do specified in the standard, and that's where the standard is. And just like the tokenizer, the parser is a state machine, and it calls its states insertion modes, and it starts with the initial insertion mode. So let's put that in. So we have a enum, and that has, for the moment, just one value that we know about. So we need an insertion mode, and then in the loop we're going to have a big switch that's going to depend on the insertion mode. And within that, we want to switch on the token type. So if we have a look back at the standard, this is the list of token types that it must deal with. So the first thing is a character token that is white space, and we need to ignore the token. So it's a character type where the token character is a white space. We're just going to break out at that stage. So we're not dealing with comments yet. We're not dealing with doc types. We're ignoring those for the moment. And then it says anything else. And there, basically the only thing is we need to switch the insertion mode to before HTML and then reprocess the token. So it's anything other than these things up here. It wants us to switch the insertion mode and reprocess the token. So that's the default. Insertion mode equals, what was it? Before HTML. Which we don't have yet, so let's put that into our enum. With Swift on the switches, it's absolutely insistent that we deal with every one of the possible options. And so because I've added in that new insertion mode, it now gives me an error that the switch must be exhaustive. So before HTML. Now, the spec said we need to switch the insertion mode to before HTML, then reprocess the token. And this is a bit like the reconsume that we had in the tokenizer. What it's saying is that we switch to the before HTML insertion mode, which is here, without grabbing another token. But this is a switch statement. You know, we can only do one of the cases when we're doing a switch. So we need to go another time around the loop to get to the before HTML. If we let that loop continue on and process normally through the end, it will get another token, which is not what we want. So what we're going to do there is continue, which means go straight back to the start loop and just just because, just to make it clear where that's going to go to, we'll label the loop up as reprocess, and then we'll say continue reprocess. So that means our code looks a little bit like the standard. It reflects it. So insertion mode before HTML and then reprocess a token. That's exactly what we're specifying there. So what we're going to do, we'll have the same pattern in every insertion mode, where we're going to switch on the token type. We're going to do exactly the same as that again. And then we've got a start tag whose name is HTML. Well, we're in our example, we do have that. We have a HTML tag and a body tag and a closed body tag, and end tags for body and HTML. So we're going to deal with that. So we need to create an element for the token with the document as the intended parent, append it to the document, put this element in the stack of open elements. So that's our case. Is it's going to be a start tag, and it's where the token name. So what we want to do is insert a node, and the node is going to be a DOM HTML element, and that's going to have a parent of the document. So in the spec it says put this element in the stack of open elements. So this is the way that the parser keeps track of where it is in the document. Every tag that it encounters, it will add the tag onto a stack. So when we get that, it'll put HTML on the stack. When we get to that, it'll put the body on the stack, and so on. And so we need to have that stack. Another variable we need. And that's going to be an array of DOM nodes. So we'll have a function insert node. So we've got an array of these things and we're adding to the end of it. But rather than an array, it refers to it as a stack. And stacks, when you add, you don't append, you push things to the stack. And when you remove them, you pop things from the stack. With Swift, we can extend classes, even if they're not classes that we have in our code or we have the source for. We can do an extension. So we'll extend array. We'll do a function of push, and the items in an array are elements. All it will do is literally, it's just another name for append. And we get an error message saying cannot use mutating member on immutable value. Self is immutable. So what's happening there is that array is a struct, and structs are value types. And value types, they assume that you initialize them with some values, and then you don't change those values after that. They're constant. But you can change that behavior by adding the word mutating, and that'll allow you to change any data within the struct. So while we're here, we'll do another mutating function to pop the top value from the stack, and that'll be an element. And we're also going to be commonly going to be referring to the current node, which will be the last node that we encountered, the one that's at the top of the stack. So we'll have a little function called current node, and that's just going to return the last item in the array. So nice little extension there that's just going to let us write things a bit more closer to the language that's used in the spec. So we've got an insert node, and we're pushing the item onto the stack of open elements there. Well, we've created a HTML element, and then we insert it, and we've put it in the stack of open elements, And now we need to switch the insertion mode to before head, then reprocess the token. So, and then use a little trick to reprocess. So let's add before head to the possible states we can have. And let's put a default in here, similar to how we did in the tokenizer. Anything that we're not dealing with right now, I'm going to mark that as not implemented. And I'm going to have the token. I'm going to print that out. Let's kill that error there. Yeah, I did indeed. Main equals equals. So one other thing that we need to do is in the content view. At the moment we're creating a dummy DOM. We want to go back to loading the HTML file. We load up the data and then we're parsing it into the DOM. So hopefully that will work. I don't know, let's give it a try. Build field, switch must be exhaustive. I mentioned this before. Not yet implemented. So it's compiled and it's given us a fatal error, not yet implemented start tag, and it's saying it's not implemented here. So that's good. We've got through there and we've got to here with start tag HTML. Okay, so we need to switch on the token type again. And that's where we'll put that. Not yet implemented. Before head, that's what we're looking for in the spec. Before head insertion mode. There we go. If it's white space, we want to ignore the token. If it's a HTML tag, then we're going to process the token using the rules for the in-body insertion mode. Actually, what we're going to do is we're going to simplify this a bit. Rather than before head, we're not dealing with head, the head section of the of HTML just yet. So rather than before head, let's say we're going to go after the head. That's not quite what's in the spec. It's a simplification of it, but it'll just cut down on the amount of code that we need to do today. So after head. But still we're going to have the possibility of white space there, which we need to deal with, and we'll just ignore that. So we're here with the start tag of HTML in after head. Is that right? No, we don't want to do a reprocess there. That's wrong, because we've dealt with the HTML tag there. We've actioned it, so we don't want to pass it on to another one. So that's where we should be. Not yet implemented start tag body. That's what I was expecting. So we're going to have a case for the start tag where the name, the token name, is body. So we're inserting an HTML element. We're not worried about that just yet, and we're going to switch to in body. Insert node. Insert DOM HTML body element. And the parent node is going to be the HTML node. And how do we specify that? Well, that's where the stack of open elements comes in. The stack of open elements. We specify the current node, and that's going to be the last one that we encountered, which is the HTML node. So that's going to be the parent of this body. So we do that, and then we're going to switch the insertion mode, aren't we? And that's going to be to in body. which is a new insertion mode that we've not got yet. So again, let's add that to the list of possible ones we can have. And it's the same pattern, token type, but let's see what comes up if we mark everything not implemented and then run it. So the next token that's got is a character token, and the string is a new line. So in body, we're not worried about nulls yet, but this is it. It's new line, so that's white space. So it says reconstruct the active formatting elements, if any. Well, we're not doing that just yet. We need to insert the token's character. Let's just do case character. And then what we need to do is insert that. So just as we've got insert node, we want to have an insert character as well. Okay. So what that's going to do is, first of all, find the parent. And the parent is going to be the current node from the stack of elements. The parent will have a list of a number of children, possibly, and if it does, then we need to look at the last one of the children and see if it's a text node. And if it's a text node, then that's where we're going to add our character. So if we're already constructing a text node, we want to continue and add this character to that. So this is saying, do we have a parent? Does that parent have child nodes? And if it does, what's the last of the child nodes? And when we get that, is it a text node? Is that what it is? If all of that's true, then we perform what's in here. So last will be the text node, and we want to append the character to it. If that's not the case, if there's not an existing text node, then we'll need to create a text node, and it'll have a parent node of parent. And with that new node that we just created, we want to add the character onto the end of that as well. So for the moment at least, that's what we need to do to insert a character. So let's see if that satisfies it. Let's see what it does. It's building, and it's built, and it's got to embody, and it's not yet implemented, and it's found the character E. So let's go back to the spec again, and it's in body, in body. So we've done the white space, any other character token, and it's doing the same. It's doing the same thing, isn't it? Except it's got the frame set tag thing, but we're not doing that yet. So essentially, we need to do exactly the same thing for any other character. So just copy that, and it's any character at all. I'm going to do that. I'm going to leave them as separate cases because, you know, we'll be implementing the rest of the spec in a later video, and there will be slight differences there. So let's see what that gives us. So not yet implemented end tag body. So case end tag where token.name is body, and we're going to switch the insertion mode to after body, and again that's a new one that we haven't dealt with before. So I'll add that to our list of possible states and create a new case for it. And we'll have the default, that we have not yet implemented it. Let's just run it and see where we are. So again, we're here, we're in after body, and we've got a character of new line, so that's white space. So we're going to be doing something like this. That's the case. What does it tell us to actually do though? Process the token using the rules for the in-body insertion mode. So that's a reprocess, isn't it? So insertion mode equals in-body. Okay, see what that gives us. Okay, so we're now in body at the end tag for HTML. So an end tag. We're going backwards and forwards between modes here. So let's see how that does. So now we're in after body, and we're not dealing with that end tag yet. Case end tag. And it was after body. Put that in the wrong place. After body. Okay. So let's see what happens there. So now we're back in body, and we've dealt with everything. So we've already got the case for the end tag name is HTML. We've dealt with that. So it's just the end of file token that we haven't dealt with. So what we're going to do is case end of file, and we're going to do a break. If we just do a break on its own, then all we'll do is we'll break out of the switch that we're in. We actually want to break out of the loop. So if we do reprocess, that's the label we've got on the loop. So we'll come out of there. Down to here, and we'll return the document. Hopefully. So there we are. It's finished the parser, and it's created document example body text. So is that actually our index HTML, or are we still rendering something else? Let's prove it. So there we go. That is from the HTML. We've got the document object model. So that's what I wanted to do for today. We're going to end here. So thanks very much for watching. If you've enjoyed this, then please like and subscribe. It'll really give me motivation to continue doing this series. All right, thank you very much. Bye bye.